Hello dear students. In today's video we are going to discuss about more about acids, bases and salts. So what we discussed in the previous chapter about chemical reactions and equations. In that particular chapter we discussed about one particular chemical reaction which you may remember, that is double displacement reaction. The reactions in which the exchange of ions that takes place, and as a result one of the product which is formed as result of this reaction is an insoluble product which is known as precipitate. So here in this particular chapter we already discussed about what is acid and what is the definition of acid. So the substances which produces H plus ions when it comes in contact with water, so that is known as acid, those substances. So again we studied that origin, according to the origin of acid. So acids are naturally occurring and they are produced in the laboratories. So as a result we can classify the acids into natural and inorganic acids. And similarly we studied that bases. About bases we discussed that bases are the substances that produces OH minus ions while come in contact with water or in the presence of water. So, in today's session, we are again going to discuss more about what type of reactions, chemical reaction, that will happen between acid and base. So, many of you know that HCl, hydrochloric acid. So, that is an example of acid, plus sodium hydroxide, which is a common base or an alkali. So, what do you mean by an alkali? The base which is soluble in water, or the bases which are soluble in water, they are known as alkalis. Sodium hydroxide, potassium hydroxide, these are examples of alkalis. So, when you mix these two solutions, HCl, hydrochloric acid solutions, and solution and sodium hydroxide solution, so they will react to form sodium chloride and water. So this is actually happening. They are exchanging their ions. As a result, they will lead to the formation of two products. The one product, sodium chloride, which you are already familiar with, that is known as common salt. So as a result of the combination of the reaction between acid and base, so we are getting salt and water as the product. So this is a general equation. Okay, this general equation you need to remember. And so as you can see, instead of HCl, if you take H2SO4, sulfuric acid and nitric acid, so we will get different products, salts. So instead of HCl, if you take H2SO4, what will be the product? H2SO4 plus sodium hydroxide. So what will happen? Instead of Cl here, sulfate radical will come. That is Na2SO4 and H2O. So if you take nitric acid, HNO3, or phosphoric acid, so as a result, sodium nitrate and sodium phosphate, these substances will be formed as a result of this particular reaction, particular salt. The salt that is formed as a result of this neutralization reaction, look at the cation will be, the cation part of the salt will be from that of the base, and the anionic part, that is chloride ion, Cl minus, the anionic part will be formed, that will be obtained from the acid. So that part we need to remember. And this reaction is also known as neutralization reaction. So what do you mean by neutralization reaction? So we already discussed about the properties of acid and bases. So acids has got what acid has got somewhat soft taste, and bases somewhat bitter in taste. So when they react, what is happening actually? They will neutralize each other's property. So as a result, we are obtaining a salt, that is sodium chloride, which is neutral in nature, which is neither acidic nor basic. Or as a result, water is also formed as an additional product. So that's why this reaction is also named as neutralization reactions. So acid, if acid is strong and the base is also strong enough, so these two strong acid and base, they will react, and as a result they will neutralize each other's property. The strength is same, they will form neutral salt. And if in the case if acid is more strong, if acid is more strong, base is weak, can the base be neutralized by the acid? No. So some acidic character will be present in the salt so form. So in that situation you will get acidic salt. So you note down that when the acid is strong but the base is weak, for example sulfuric acid and reacting with magnesium hydroxide, so magnesium sulfate will be formed. This is a acidic acid, acidic salt. And similarly you can see when a highly concentrated base or a strong base, the strong base means it can give large number of OH minus ions. So when you take sodium hydroxide, potassium hydroxide, these are examples of strong base. When a strong base is neutralized by a weak acid, so will that acid be neutralized completely, or will the base be completed neutralized? No. Some basic properties will remain. So take an example, methanoic acid or carbonic acid. These are examples of weak acids because they won't ionize completely in the solution. So when you take sodium hydroxide and carbonic acid, so as a result sodium carbonate that will be formed. Sodium carbonate we'll study about it, which is also known as washing soda. Washing soda, oh, that is actually a basic salt. So in this way, acidic salt, basic salt and neutral salt. If the strength of the acid is more, the salt formed will be acidic salt. And if the strength of the base is more, then the salt formed will be basic salt. And if the both the acid and base, if both the acid and base are equally strong or they are equally weak, then the salt formed will be neutral. And accordingly we can classify about different based on the type of anions present in or cations present in this particular salts. So we can classify them into different family of salt. Say sodium salts, sodium family, sodium chloride, sodium sulfate, sodium nitrate, these are examples of sodium family. And in terms of chloride family also we can name, say how we name that chloride family: sodium chloride, magnesium chloride, calcium chloride. These all anions are same. So that's why we name it as chloride family. The family of salt is known as chloride family. And we can see just like this hydrochloric acid, this is known as parent acid, this is known as parent base, salt and water. So this is what particularly happening when acid and base react to form salt and water. And this reaction is known as neutralization reaction. It is also a type of double displacement reaction. So I hope you understood. I will continue the video. And if you got any particular doubt, you can clear it with me and ask me. Okay. Now you look at this particular solution. What will happen when an acid or base, when that is dissolved in water or when that is mixed with water? So this particular activity, look at this picture. This particular activity is explained in your textbook. So we can see. Let us look at this particular experiment one by one. So I have taken a small beaker, then taken dilute HCl in the beaker and a small cork piece, two cork piece, and two iron nails are fixed onto the cork piece. Here you can see. Now, see these iron nails are fully immersed in dilute HCl acid. So what do you mean by dilute HCl acid? Dilution means what? You are mixing acid with the water. How this mixing is done? We are taking some amount of water, then small amount of acid, then acid will be slowly added to water and then we will mix. Don't add water to acid. because it will create explosion. So it is this dissociation reaction. This is highly exothermic in nature. And again, we can see that what is happening. So we are connecting battery over here, then one bulb, then switch, and completing the circuit to the uh, next iron nail. So what will happen? So when you connect this particular iron nail, the end of the iron nail to this particular, so what will happen? As you switch on the device, uh, electric current will start flowing in the circuit, and as a result, the bulb will start glowing. And similarly, you can see what is happening with this acid. So why the acid starts conducting electric current. So we already discussed about what is electric current, the flow charges. So here what is happening when we mix HCl, hydrochloric acid, with water. So what is happening? The two hydrogen atoms that are present in water molecule that will react with the H plus ion. H plus ion that is present in the acid. H plus ion that is present in the acid will react with these two hydrogen atoms that is present in water plus this oxygen, so as to give a product that is called hydronium ion. Hydronium ion, which is H3O plus. It has got one positive charge because H plus. Because this hydrogen atom has lost one electron to chlorine, so it has become H plus, and instead chlorine becomes Cl minus. So this hydronium ions are transient exclusively, so they cannot exist for a long time. So immediately what will happen? They will get dissociated, and this process will continue at a very high rate. So as a result, this ion H plus ions, that particular ion that is lacking one electron, that will accept one electron, and as a result, this particular circuit will start conducting electric current. So as a result, the bulb will start glowing. See here, we can see in the solution what we will get. As the electric current starts passing through the solution, so already what is happening? HCl when it is mixed with water, here H plus ions are, Cl minus ions are already present in the solution. So as a result, what will happen? So as we know, H plus ions that are present in the solution, being positively charged, they will get attracted towards the negatively charged electron, which is known as cathode. The H plus ions will move towards the cathode. We already studied the electrolysis of water. So after reaching here or this iron nail, they will accept electrons and liberate it into hydrogen gas. So at the same time, what will happen? The Cl minus ions, as they carry extra electron. So what will happen? They will get attracted towards the positive terminal of the electrode that is known as anode. So after reaching here, what will happen? It will give its extra electron to this particular electrode, and they will become chlorine atom. So this two chlorine atom combine to give chlorine gas. Chlorine gas will be released at this particular electrode, anode, and hydrogen. So after accepting one electron from this particular electrode, so what will happen? We already studied that electrons are going from negative terminal to the positive terminal. Is it? So these electrons, after being accepted by hydrogen atom, so what will happen? Two hydrogen atoms will combine, H plus H, so as to form hydrogen molecule, which is a gas. So that gas will be liberated at the cathode. So this is what happens. So in this way, the circuit gets completed, and the bulb will start glowing. So this is what happening when an acid is dissolved in water. And similar is the case with base. You can look at this particular equation. Sodium hydroxide, when in the presence of water, it will dissociate. So there exists actually a strong interionic force of attraction. So in electricity, these are oppositely charged. Sodium is cation and hydroxide is anion. So these are oppositely charged. So they will be binding together in the solid state or even in the unionized state. So they are bond, the strong bond of attraction, the strong force of attraction is existing between those oppositely charged ions. So when you mix this particular compound, sodium hydroxide in water, what is happening? These ions will get separated. They are now free to move. So they will get ionized to form Na plus and OH minus ions. For this particular, this is the specialty. Hydroxide ions are the specialty of bases. Bases will produce hydroxide ions. So similarly, we will get hydronium ions. We will notice this, but H plus aqueous. Aqueous means what? So H2O molecule is already present plus this proton. We will notice this. H plus ions are produced by acid when dissolved in water, and similarly OH minus ions. OH minus ions are produced by bases when they are dissolved in water. At the same time, we can see also here again NaCl, Na plus and Cl minus. Even salts also conduct electricity. Bases also conduct electricity. Acid also conduct electricity. So with this particular example, we can prove that acids, salts, and bases, these all conduct electricity. Okay, but not alcohol or sugar solution that are also containing OH groups or hydrogen. Sugar is containing C6H12 oil or and similarly C2H5 OH. These are all alcohol. But even though hydroxide group is present in alcohol, alcohol cannot ionize to liberate that OH minus. So this will not conduct electricity. Solutions of acids, bases, and salts. These only will conduct electricity, not glucose, alcohol, etc. Now let us look at the next topic, that is known as pH. How will you notify this particular, whether this particular hydrogen or according to the concentration of hydrogen present in an acid. So we can classify the acid into strong acid, weak acid, then neutral substances, which we already discussed here, then basic substances. So there exists a scale known as pH scale. pH scale is actually proposed by a scientist called Sorensen. So which actually express the power of hydrogen in different substances, solutions of acid, bases, and salt. So how much amount of hydrogen is present, or H plus ions, the concentration of H plus ions, how much is available in that particular substance. So as a result, we are grading it into a scale that is known as pH scale. Here we can see it ranges from 0 to 14. The scale ranges from 0 to 14, where 0 denotes maximum concentration of hydrogen. Then as we move towards this side, so what will happen? The concentration of hydrogen ion gets decreases, and as we come to the right hand side, that is towards the 14 side, the amount of hydrogen ions become very less, and as a result, the substance will somewhat show more basic or highly basic in nature. The substances with pH 14 are strong bases, and the color of pH paper. One pH paper is there not to test the pH of that particular substance, acid, base, or salt. So the pH of one particular substance, if the pH of one particular substance is 7, that means that substance will be neutral. If less than 7, this substance will be termed as acid. and greater than 7, these are termed as bases. See, at the same time, the concentration of OH minus ions, as you move to from 0 to 14, the concentration of OH minus ions is increasing. This particular term. The concentration of OH minus ions is increasing, but H plus ions, the concentration of H plus ions is decreasing as you move towards right. As you move from right to left, H plus ion concentration is increasing. So towards this left hand side, you see strong acid. The middle neutral 7. pH of pure water is 7. Is neutral. Then HCl and all these are highly acidic. So pH paper will show red color and the pH will be nearly 0. And sodium hydroxide approximately 40, nearly 40. This is highly basic in nature. So I hope you understood this particular part. Read the chapter well, and the remaining portions it's about the preparations of different types of salt and its chemical preparation and its uses. Chloralkali process is one of the important part, and then uses of different salts and how these are prepared. And towards the last part of this particular chapter, we have already discussed in the lab activity that water of crystallization. There is a fixed number of water molecules that is attached to the each formula unit of a salt. We can test it by heating it small amount of ferrous sulfate that contains 7 molecules of water. So while you heat, what will happen? That particular water molecules will get evaporated, and as a result, the green color of the copper sulfate or the ferrous sulfate solution, ferrous sulfate crystals that will go out. And in the case of copper sulfate, if you are using the blue color of the copper sulfate solution, that salt that will get decolorized. So this particular activity proves that these salts contains water of crystallization, and go through all the uses of salts and how these salts are prepared. So that part I don't think need much explanation. Go through the chloralkali process, out of which much important products